All right, so today we're taking a look at how to solve quadratics like this algebraically. Now we've done problems like this before where you've been able to graph it, but I want to show you today how we'd go about doing it without actually making the graph. So first thing we want to do is we want to get the x squared part by itself first.
Or do we?
In this case, that means adding the 1 to both sides. So if I add 1 to both sides, notice that leaves me with x squared equals 9. Yes, be writing this workout as I'm putting it up here so that you're going to have this as a reference to look back on. Now that I have x squared equals 9, I need to get rid of the power of 2. I need to undo the squared. Now what undoes a square?
Square root.
Square root, yeah. So if I take the square root of both sides, I end up looking at this.
Equals 3.
And so the square root of x squared, the reason why we take the square root of it is because it cancels out the squared and it just leaves us with whatever we had been squaring, so it leaves us with the x. And then square root of 9 equals 3. And so it looks like here x equals 3, but there is going to be another little nuance that we're going to have to add to this, but we need to do a little bit of other work first. We have done these by graphing before, and I actually want to see how it would look if we graph it, because it's going to bring out something that we then have to go back to our algebra with. So, on your graphing grid, please solve this equation by graphing it. Alright, so in making this graph, remember we basically graph the left side, so x squared minus 1. In that case, the minus 1, remember, means down 1. And then we make our graph from there. So this is what the x squared minus 1 looks like.
That's not over 3.
And so then when we go to graph the right side, that's like basically just a y equals 8. And so remember, that ends up giving us a horizontal line, because that represents all the different numbers where y can equal 8. Because x can be anything in that kind of a case. And so our solution, that's where those two cross. And so notice that when we solve this by graphing, we actually got two different solutions.
Because it crosses 2 times.
Yeah. And so when we take a look at solving this, we should actually be seeing two solutions. We should be seeing that we get x equals 3, which we found, but we should also be finding that x equals negative 3. So why didn't we find that when we did our algebra? Because it should be the same thing. Well, it's because we got to add something to our process here, because our graph is correct here and it's showing us the right stuff. When doing our work that we did earlier here, there is one additional rule that we have to add into this process. And that is that when taking the square root of both sides of an equation, we must account for both the positive and negative square root. What that means is that we put a plus or minus there in front of the square root as soon as we take the square root of both sides of the equation. So go back to your algebra that we wrote down for that first problem and add in that plus or minus in front of it. And that plus or minus means once where it's positive and once where it's negative. That's what that plus or minus symbol means. It's just allowing us to still write it as a single line instead of a couple separate lines. And so then, as we take a look at the algebra, x equals plus or minus 3, that's exactly the same as writing x equals 3 and negative 3. And so we get those two separate solutions.
Wait, can you put that on more maps? That's busy complaining.
All right, now we're going to be practicing that with a few different problems here, seeing some different nuances, variations. So please write down this problem. 3x squared equals 12. So in the last problem, we had to get the x squared by itself first. It's going to be the same thing here. So then in this case, that means I have to get rid of the 3. And so what do I do to get rid of the 3?
Answer's 2.
Yep, we divide both sides by that 3.
Answer's 2.
So when we do that, we find that x squared equals 4. Now, what do I do to get rid of the squared? What am I going to do to both sides? Square root. Square root undoes the square.
You cube it.
This is the tricky part though, because this is where we have to remember to include that plus or minus. So when you introduce a square root into a problem, that is when you have to include the plus or minus. And then once you've done that, then we can go ahead and take that square root and get our final answer. Okay, next problem. Write this one down in your paper and start thinking about what are you going to do first. All right, so with this one, we have a couple different things going on at the start, right? We have both this 5 here and the 7 here. Which one do I need to get rid of first?
The 7.
The 7, yep. Because remember, when solving an equation, we're undoing it so we go backwards through the order of operations. So first step, get rid of the 7. And so finish it out from this point. Think about what do you do to get rid of the 5 now. All right, so now that we got rid of the addition and subtraction, I now have the 5 times x squared, so I divide both sides by 5. And 45 divided by 5, of course that gives us 9.
Done.
Now we have x squared equals 9. Now we can go ahead and deal with the squared. So notice our first priority is always get the x squared by itself. All right, so having done that, what do I do? I keep asking this because I want it to become an easy answer. What do I do to get rid of the squared?
Square root.
Square root. I want that to become a natural thing. And when we take the square root of both sides, that rule we have to remember is to include the plus or minus. Make a note to yourself if you need to do that, that we need to include plus or minus whenever we introduce the square root. Having done that, we can now go ahead and get our answer. X equals plus or minus 3, which is okay to write, but it's even a little bit better to write x equals 3 and negative 3 like this.
What I like.
We're now going to do one last problem like this here together. So please write down this equation and then see about how would you go about solving it. All right, so the first step is actually kind of look at this as if it's like 2x and x over here. It works just like we did when we did those, where I need to start by moving all the x's to one side and the numbers to the other. So let's say I want to move all the x squareds over to the left. What am I going to do to both sides?
You'd have to. You minus 1x. I always do the lower on the lower one.
What?
We subtract the x squared from both sides if we're going to do that. Now notice what that does for us. It means that this x squared minus x squared on the right side, that goes away because it adds to 0. And so you're just left with a negative 3 there. All right, now you have x squared minus 7 equals negative 3. Continue from there to finish this problem out. All right, so next up, I'm still trying to get the x squared by itself. So go ahead and add the 7 to both sides. When we've done that, now we got x squared equals 4. And then what do we do to both sides? Square root. Yep. And when we do the square root of both sides, we include the plus or minus. So we should end up with a final answer here of x equals 2 and negative 2. Both of those are valid solutions. One thing I want you to note as you take a look at the problems that we've just solved algebraically is that we started off with ones that we could solve by graphing it, right? But notice this one. Could you have solved this one graphically? Well, if we were trying to graph the left side here, what does the 2 do? Now I'll tell you, that 2 is something we haven't dealt with in this class yet this year. It's actually a vertical stretch. It's not going to shift it anyway.
I know what it is.
Now if you knew that, you could go ahead and graph it, but I want you to be able to do it without having that knowledge, and so that's partly why we have these skills, so that we can deal with what happens when it doesn't work nice and tidy on the graphing grid.